Let's take a look at section 0.3, the first part of it, which is graphing quadratic functions. So again, this is all review from Algebra 2, but we'll freshen up our skills. So what is a quadratic equation? So a quadratic equation is an equation in which the variable x is raised to the power of 2. Okay, so it's not to the third power, to the fourth power. It's not linear where it's raised to the first power. Our highest power is a 2. We call these quadratic equations parabolas. Okay, so the graph of a quadratic, like I said, is a parabola, which is a U shape. And what's really important to know is the parent function. A parent function is the most basic function of whichever family we're talking about. In this case, we're talking about quadratics. So the most basic function we can have is y equals x squared. We can then have sort of relatives and children of that where maybe it says y equals x squared plus 4, or y equals 2x squared, y equals negative x plus 7 all squared. Those are transformed functions, but the basic parent function is y equals x squared. And you want to have that parent function's graph memorized. So what does that look like? It's a U where the bottom of the U is at the origin, 0, 0. And then 4 more key points you want to know is that we go up 1 over 1. We don't have any slope, but we go up 1 over 1 in both directions from that bottom point. And then we also go up 4 and over 2. So if you have these key points memorized, it'll make your graphing process a lot smoother. And so there's our parent function. Again, the bottom of the parabola is at 0, 0, the origin. And then we have points that go up 1 over 1 in both direction and up 4 over 2 in both direction. Okay? Solutions of a quadratic equation. We can find solutions in lots of ways. Algebraically, we can find them by plugging in 0 for y and solving for x. Graphically, we can find them by looking at the x-axis. So, solutions of a quadratic equation are the x values that make the equation equal 0. So again, algebraically, plug in 0 for y and solve for x. That could mean by factoring, by the quadratic formula, by completing the square, which we will review in further sections. And these solutions are also known as roots, zeros, or x-intercepts. All of these words, 4 words, solutions, roots, zeros, x-intercepts, are interchangeable. Our axis of symmetry. Axis of symmetry is the imaginary line that passes through the vertex and creates 2 symmetric pieces. Okay, so if I was to sketch that on my parent function, which I'll use orange here, it's this imaginary line, I'll use dotted, that passes right through that vertex and creates 2 symmetrical pieces. So we can see if I flip that U over, it would reflect right on top of the other piece. Now, very important that you memorize this formula. The equation for our axis of symmetry, or AOS, is x equals negative b all over 2a. And we will discuss where that negative b and the 2a come from as we move further along. But an axis of symmetry is a line, not a point. So you always want to make sure you're including the x equals with that. Our vertex is the lowest or highest point of our graph. okay? And then everything is sort of symmetrical from that vertex. To find the vertex, we take the axis of symmetry and plug it in for x. To find y, okay? And often, then we have an ordered pair, and often that vertex, instead of just simply saying xy, we also use variables of h and k, okay? And again, we'll see more of that in our examples to come. Now, a maximum or minimum. The maximum or minimum is simply the vertex, but we have a maximum when the vertex is the highest point. So a max when vertex is highest point, which means the graph opens down, and our A value, which again we'll discuss momentarily, is negative. We have a minimum when it's the opposite. So when your vertex is the lowest point, the graph opens up, and our A value is positive. Okay, so key pieces of our quadratic graph is that first off, we call it a parabola. It has a vertex, which either acts as a maximum or a minimum. And then we have an axis of symmetry that's an imaginary line that passes through that vertex. So when I say, let's go find the axis of symmetry and let's find the vertex, I've been using these letters of A and B and so forth. So where do those come from? Our general or standard form is where they come from. So our general form is y equals ax squared plus bx plus c, where a and b are coefficients and c is our constant. Now, b and c may be 0, and that's okay, but a must exist so that we have that x squared term. If a is 0, then there's no x squared term, and therefore it's no longer a quadratic. So this is where we come up with our axis of symmetry and finding our vertex is the A, B, and C values from here. We also have vertex form, which we'll look at a little bit, but we'll look at that further on in the course as well. And that's in the form of y equals A times x minus h all squared plus k. Again, we have our A value. And this time around, we don't have a B and C value. So we're not going to use our formula of vertex of negative B over 2A. In fact, our vertex literally just comes right from the formula. So H comma K is the vertex. Hence why we call this vertex form. So let's look at some examples of graphing. I'm going to do example 2 with you, and I'm going to ask you then to go back and try example 1 and 3. So if we look at example 2, we're in standard form. So I'm going to jot down what A, B, and C are. A is negative 2, B is 4, and C is negative 9, right? A, B, and C. So we'll start with our axis of symmetry. Again, axis of symmetry is x equals negative B all over 2A. So that would be negative 4 all over 2 times negative 2. So x would equal positive 1. Again, don't just say 1, it's an equation, so x equals 1. Now, to find my vertex, I take that value of x equals 1 and I plug it into the original equation. So where I see an x, I'm going to put a 1, and then I'm going to simplify. So this gives me negative 2 plus 4 minus 9. Negative 2 plus 4, make sure we go in order, right? Negative 2 plus 4 is 2, and 2 minus 9 is negative 7. So my vertex is that I plugged in a 1, and I got negative 7. So I'm going to plot those points for now. So 1, -7 is here. Okay, and then we know we'll have an axis of symmetry that's going to pass through that vertex. Now, how do I find more points of my parabola? You have two options. You can make a table. And so with that table, I always encourage you to have your vertex be in the middle, which is 1, -7. From here, we'll do a few test points. So for example, 2 and 3 will test, and 0 and -1. So we'll actually plug those in. I'm going to start with 0. If I plug 0 in, that's also the way to find my y-intercept. Okay, a y-intercept is found by plugging 0 in for x. So if I plug 0 in, we get y equals -2 times 0 squared is 0, plus 4 times 0 is 0, minus 9. We get y equals -9. So there's a point. Now, if I plot that, here's the good news, is we know axis of symmetry creates symmetry. So if I have the ordered pair at 0, -9, it means when I plug in a 2, I should also get -9. And we can continue on by testing even more points. As you can see here, this graph is gonna end up going down and off of my rest of my chart. But there is the graph of this equation. Without having to do a table, we could also use the rules and transformations from above. Remember, as I recalled, in that parent function, we have our axis, our vertex, and we went up 1 over 1. And then we went up 4 over 2. Instead of going up 1 over 1, this time around, that a value is negative, so we're going to go down. And because we have a stretch of 2, we're not just going to go down 1 over 1, we're going to go down 2 over 1. And we'll talk more about transformations, but you may recall that from Algebra 2. If you're a little unsure with that, stick with your table. It's good to have at least 3 to 5 points so that you can make that curve and the width and skinniness appropriate. So now let's analyze. What are my roots? AKA, what are my solutions? Well, solutions are where our y value is 0 or our x-intercept. So I look along this area right here. Where am I crossing that x-axis? And in this case, we're not. So what that means is that I have no real solution. We may have imaginary ones, but I do not have a real solution. If I did cross the x-axis, then I would jot down those ordered pairs. And last but not least, do I have a maximum or a minimum? Well, that graph is going down. I know that from the negative out front. And so because it's going down, we have a maximum. Okay, so what I'd like you to try to do is practice graphing example 1 and example 3, picking out those A, B, C values, finding axis symmetry and vertex, and filling the chart in. Last but not least, let's review some of our vocab. So a quadratic function is a function that can be written in standard form, which is y equals ax squared plus bx plus c. And vertex form, which is y equals a times x minus h, all squared plus k. Notice we have squared terms in both of these. That's what makes something a quadratic. Number 2, every quadratic function has a U-shaped graph called a parabola. Why don't you continue by filling in the rest of the blanks, and all that vocabulary comes from above.